This video is a demonstration of the component library. The component library features 28 antennas and 8 platform models. The platforms are large structures such as aircraft, vehicles, and other large structures suitable for antenna placement studies. The antennas are versatile in their definition to support frequency scaling, the use of different solvers, and the option to include a ground plane with the antenna. When antenna components are added, a set of drop-down boxes and checkboxes can be used to customize the component for the specific application. Most importantly, the models have been designed to be fully scalable according to the frequency. When antennas will be used in an antenna placement application, typically the option to add a ground plane is unchecked. In this demonstration, we will show how easy it is to select an antenna and place it on a platform. Specifically, we will create a blade antenna and place it on a helicopter platform. Start Altair Feko and on the Home tab, click on Component Library. We will first add a platform, which will be a helicopter. Platforms are identified by the yellow P icons, while antennas have a green A. We add a platform by clicking on Helicopter. A description as well as images are shown. Now click Create Model. Secondly, we will add a blade antenna. Click again on Component Library. The component library allows to search for components. As we start typing, the list of matching components will be narrowed down. Now click on the blade antenna. A preview is given of the geometry, 3D and polar patterns, as well as the input reflection coefficient. In this dialog, we specify the solution frequency and/or range, the solver type, whether the model should have a ground plane or not, and if we will require placing the antenna using the Align tool. Our frequency of 1.6 GHz will result in an electrically large model. Therefore, the solver will be MLFMM. For this demo, we will solve at a single frequency, but we can also add a frequency range. Lastly, since the antenna will be placed onto the helicopter, we uncheck the ground plane option. Now click Add to Model. Altair Feko opens the Align tool for placement of the blade antenna on the helicopter. The blade antenna is imported at the origin since the default workplane is set to the global origin. We keep the origin workplane as is and only modify the destination workplane. We will place the blade on top of the helicopter. Press and hold together Ctrl and Shift and position the mouse at the center of the face shown. Then select. Altair Feko shows a preview of the antenna position as well as its orientation. Then click OK. The blue-colored sphere shows the already created 3D far-field request. To ensure that the mesh for the helicopter and the mesh for the blade are electrically connected, we must make a union of the blade and helicopter. Select both parts in the tree and on the Construct tab, click on Union. Now the model is ready to create the mesh. We see that suitable mesh sizes have already been set. Also note that Altair Feko has already created a suitable port and voltage source. This is indicated by the port annotations. If we zoom in, we can see that the mesh has been refined automatically around the feed area, and a continuous mesh has been generated between the connection point and the helicopter. Now we can save the model. To solve the model, on the Solve Run tab, click on Feko Solver.